Okay, this is Ms. Kosh, and I wanted to talk through geometric sequences for my band kids who are going to be out, or anyone that needs to catch up to what we were doing. Okay, so as we get started, a geometric sequence is a sequence with a common ratio. So that means if I take the second term and divide it by the first term, I'd get R, my common ratio. Or if I take the 10th term and divide it by the term that came right before it, the 9th term, I'd get R. In general, what we can say is that the nth term divided by the term that came right before that, the n minus 1th term, that always equals R. Okay, so let's look at an example. Say I tell you the n value and then a sub n, 1, 2, 3, 4. Okay, let's say I have something like 3, 6, 12, 24. If I have something like this, you'll notice that what I'm doing each time is I'm multiplying by 2. So just like in an arithmetic sequence, we can write the recursive rule. The recursive formula, you always have to tell me where to start. In this case, we're starting at 3, and what to do. So g sub n is equal to the term right before it. Oh, and then I'm going to take that term and multiply it by 2. Typically, I wrote this funny. I typically would write it this way. I don't know what I was thinking. I would say g sub 1 equals 3, and I would say g sub n is equal to 2 times g sub n minus 1. There's nothing wrong with either one. This is what I tend to do. Don't know why I did it that way. So let's now think through what's happening so we can come up with an explicit formula, because our explicit formula would be for the nth term. So notice this would be 3 times 2. Well, this takes that, 3 times 2, and multiplies it by another 2. This takes, right, because this is 4 times 3 is 12. This takes what we had previously and multiplies it by another 2. What you may notice is that this is 3 times 2 cubed, and this is 3 times 2 squared, and this was 3 times 2 to the first power. Well, notice right here, this would be 3 times 2 to the 0 power, because anything to the 0 power is 1. And so I see a connection between the term number and then the exponent. If you notice, the exponent is 1 less than the term number. So I can say for this particular nth term, it's 3 times 2 to the n minus 1. And so this, g sub n, if we write the explicit formula g sub n would be equal to 3 times 2 to the n minus 1. Or you could put this in parentheses, 3 times 2 to the n minus 1, or sometimes I might even say 3 times 2 to the n minus 1. Pick one, I don't care. Okay, so in general, what we can say, the general form would be, and this was what I was starring and boxing and having a fun time in class, g sub 1 equals g sub 1. And that g sub n is equal to r times g sub n minus 1. It's the common ratio times the term that came right before the nth term. That's the recursive formula. The explicit formula would be that g sub n is equal to g sub 1 times r to the n minus 1. That's our general form. So let's do a quick example. Let's say I tell you that g sub 1 is equal to 625, and g sub n, I'm making this up as I go, is equal to 1/5 of g sub n minus 1. Or no, let's say 4/5, just for the fun of it. What I can do, they're asking me, they didn't ask me, but I'm telling you, they're asking us to find the first 4 terms. So what I can do is I can put in 625, and then I want to multiply that by 4/5. And so the first term was 625. And, okay, hang on, I can't keep everything in the screen. Oh, maybe like that. Okay, the first term was 625. The second term now is 500. And then I can just keep hitting enter, 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 and I can find all sorts of these terms. So I lost track now. So they wanted the first 5 terms. Here's number 1, here's number 2. Number 3 would be 400, number 4 would be, and number 4 would be 320. Okay? Did you like how I used the calculator and helped me? I enjoy that, so it's gone now. So the other possibility would be, let's say I have u sub n is equal to, say, 32 to the 3/2 to the n. Now this one I did in class something similar, or I at least did in first period. I'm making this video before my other two. Be careful. We normally think this is the first term, but you always have to plug in 1. This is not the same. I didn't follow the rule exactly. Notice it's usually n minus 1. So what I have to do for the first term when I plug in 1, I have 32 times, well, 3/2 raised to the first power. There we go. So the very first term here is 48. And then I can come back here and raise this. Can you see that? Raise it to the second power. Okay, then that would be what I get when I plug in 2. I can come back here, raise it to the third power. You know, it would have been better to use a table, but I'm too lazy at this point. And I could have gone to the back. Anyway, whatever. Nope, wrong button. And there's the first 4 terms of that sequence. Okay, let's say, here, let me show you what I mean by the table. If I come menu and go into my table, I can type in, let's say I've got 729 times 2/3 to the n minus 1. Oh, be careful. This, I just hit this button down here, which means negative, and the calculator makes a difference here. So I need to make sure I hit this button for subtract. So n minus 1, x minus 1. So then I can go look at my table, and what I want to do is, this is me. This is behind the scenes of what Ms. Kosh does while she's teaching this. If I want to say, okay, you know the second term is 486, and you know the, let's say the fifth term is 144. You don't know this other stuff, but I did want to show you how to use the calculator, and you can create as many of these as you want to practice. Say I have these 2 terms, and I need to find the nth term. Well, so you'll notice here's the first term, then we have our second term, and then our third, our fourth, and our fifth term is 144. Notice I'm going to multiply 1, 2, 3. I'm going to multiply, to get g sub 5, I'm going to start at the g sub 2 term and take n, I lied, take r and cube it. So notice I'm multiplying by r 1, 2, 3 times. So, and also 5 minus 2 is 3. So then I can plug in the pieces that I know. 144 is equal to 486 times r cubed. I'm going to grab my calculator, go back to our main screen here. So what would I have? I had 144 divided by 486. That number means nothing to me. Oops, I didn't mean to hit a button. That number means nothing to me, but if I change it to a fraction, all of a sudden life is grand. And I can see that 8/27 is equal to r cubed. Well, now I don't even need a calculator. I know that r itself would be 2/3. Okay, so if I have that, now I need to come and figure out what the first term is. From here, I would just multiply by 3/2 to move backwards, but let's just get used to using the formulas. So g sub 2 was 486 is equal to g sub 1 times r. So now if I multiply both sides by 3/2, if I'm going too fast, put me on half speed. Sorry. 486 times 3/2, and that gives me my g sub 1 is equal to 729. So now when I write my rule, my g sub n is equal to g sub 1 times r to the n minus 1. And that becomes the rule if they have given me 2 random terms. The only thing to be careful about is if, say I tell you the first term, so we're going to use a sub 1 is equal to 2, and a sub 3 is equal to 8. If I do something like that, I'd pick this to be easy on purpose. A sub 3 is equal to a sub 1 times r squared. 8 is equal to 2 times r squared. When I divide, 4 is equal to r squared. Keep in mind the cheer still applies. So square root, plus minus is still valid here. So I get that r is equal to plus or minus 2. So there's actually 2 geometric sequences that will have, this is its first term and this is its second. One of them would be 2, then 4, then 8, then we could keep going 16, and then 32. The other one would be when this is a negative 2. So I'd have a 2 times negative 2 is a negative 4, times a negative 2 is 8. times a negative 2 is negative 16, then a positive 32. So be careful with that. If you're taking the square root or the fourth root or something like that, you have to be aware that there could be two sequences of real numbers like that. Okay, I'm going to make another video talking about summation, so stick around for that.